Hello and welcome to C++ Weekly. In this episode, I want to do another tool spotlight. I know sometimes these are well accepted, and this one is going to be about scanlib. Scanlib is a modern replacement for scanf. Of course, my name is Jason Turner. I am available for code reviews and on-site training. I also give classes and workshops at conferences around the world. Be sure to come to one of those workshops, and you can look in the video description for more information about that. This episode, I believe, is going to be very straightforward because this will be just to make you excited about the project. Perhaps call your local C++ committee member and see if you can help get something like this actually approved for the C++ standard. This episode is sponsored by JetBrains, and I wanted to let you know that I do personally use CLion in my work. I find the refactoring tools to be particularly valuable. The safe delete feature has saved me a ton of time when I've been doing refactoring on large projects. I can get analysis of my compile time checks and see when something is wrong or fails to compile right here in my IDE. So be sure to check out the links in the video description for a discount code and more information about how you can check out CLion. It is just like format or lib format, or however that is written, but for parsing. Again, this should be pretty straightforward. It has way more features than this. We're just going to go over some very simple stuff here. This library is on Compiler Explorer, which is one of the reasons I went ahead and decided to do this episode, because it makes this kind of thing incredibly easy to do. So I have created this string view. I don't know why I put it in braces. Let's do this. The string view is the input string that I want to parse, and it is simply the value 42, space 43. The result object is something that is testable for Boolean. So I can say if the result is true, if it evaluates to true, then I know that I have got a couple of values in here. And I can extract them nice and cleanly with a structured binding. Again, I have this structured binding declaration set but not used. That is the only error happening here. Let's go ahead and print these things out. As you can see, it was just that simple. I gave it a string that I was expecting to match some sort of syntax here for it to parse, and it did parse it. So how rigid is this? If I remove that space after the comma, does the input string explicitly require a space after the comma? And it does not. It was able to parse that. So white space, I believe, is skipped by default, but everything else is not skipped by default. There we go. So I'm not getting anything printed out because I didn't have this comma. And if I were to try to sneak in a floating point number here, is it going to parse just the first part of that integer? Or is it going to give me an error and say it was not able to parse this string? There, it truncated that thing to an integer. If this project is interesting to you, be aware that it is something that the committee has been looking at for standardization. It is currently on revision 5, and I believe this was last updated back in October of 2024. The paper number is P1729. You can check this out, use the library, and contribute to this, because I think this would be an outstanding addition to the C++ standard library. Right now, trying to parse is just so much more difficult in C++ than it should be. So thank you for watching this episode of C++ Weekly. Be sure to subscribe, and I will catch you at an upcoming conference.